Okay, so it's time to finish up and wrap up the spot welder. And so I got some parts. I got a few relays from eBay, and I got a latch here that's going to go on the top to clamp it down. Now I was going to make my own mechanism for clamping that down, and that's actually why I did that other video for the lost foam casting, because I was going to cast all of the aluminum parts to make the latch, but I decided to just make it easier. I will get back and look at the lost foam casting at a later time. I'm not going to mess with that anytime soon. But anyway, so I'll get back to this later. I'll talk about that later. For now, let's take a look at the electrical side of it. I got two relays here. This one I had. This is a timer relay. And this is actually a time delay relay. It kind of works opposite as the way it did when I first got it. But I can still make it work. What happens is you turn the dial on top to set the time that you want, and it goes from 0 to 10 seconds in about half-second intervals. So you set the time that you want, and what happens is when you energize the coils, it will delay for that many of seconds. Like if you set it for 3, it'll delay 3 seconds, and then it will energize. And I thought when I first got it that it would energize for 3 seconds and then relax, but a little different. So we can still use it. Now this has 2 sets of contacts. Each set of contacts can only handle 5 amps. So I'm actually going to wire those in parallel to then drive this relay. This is a 120 volt relay, and it also has 2 contacts, and each contact here can handle 10 amps. So I'm going to configure these in parallel so this can then handle 20 amps, which is about what the spot welder pulls. Now I'm assuming that, again, I think as I said in a previous video, I'm assuming it's 20 amps continuous. So even if I go to 21 or 22 amps for a couple of seconds, should still be okay. And so let's take a look at how we're going to implement these, and we'll take a look at what we need to wire these in here. So if we look at a schematic, typically what I do when I'm trying to design a circuit, I'll start with what I know, I'll start with what I have, and I'll also put in what I think I'll need. So I'm going to start over here with the main plug, and that marker's kind of worn out. We'll see how it goes here. 3-prong plug obviously will have a ground, and that just got screwed through an eyelet to the transformer itself. And another lead will bring that out to a junction block where we'll have 4 points, and then the other one will come out to another junction block where this one will only have 3 points, 3 connections. I also have a foot pedal. I'll just put the foot pedal right down here. So that will be the foot pedal switch. And we also have a transformer, and I will just put the transformer over here. We have these secondary coils with the part that actually does the welding, the clamp, transformer, and then the primary windings. Okay. So the idea here is to have this relay drive the coils or power the coils. And what I want to do is when I press on the pedal, I will energize this relay, and I'll send the power through the 2 contacts of the relay to the coils. So I'm going to put the relay in. Let's put it right about here. And the relay has coils and 2 sets of contacts. And I'll just draw the energized contact of each. That marker's kind of hard to make a nice drawing here, but you get the idea. So two sets of contacts each. And again, we're going to wire those in parallel, so we'll just connect those here up to the coil. And we will connect those here, and we're going to take that up to the junction block here. And then the other end of the primary will just go up to that junction block right up there. So what happens now is when we energize that relay, I then send power through the relay, through the coil, and back. So I need to energize the relay. And I said to energize the relay, I want to use the foot pedal. So I'm going to take the foot pedal and to the junction block, and the other part of the switch to that coil of the relay. So that takes care of one leg of the relay. Now the other leg of the relay I want to be controlled by the timer relay. So I'm going to put that other timer device, that timer relay, in right here. And I'll just put, instead of drawing the coils, I'll put TD for time delay. And this also has two sets of contacts. Now with this one though, I want to use the relaxed set of contacts. Since remember what happens, as soon as we energize that time delay, it will delay for so many seconds and then energize. So I want it to drive the other side of this coil here, but through the relaxed contacts. So I'm going to draw in the relaxed contacts. And again, I'm going to put those in parallel. And so this side will go to that coil, and then this side will go to our power block right over here. Now the time delay, we'll get power from this block here, and I want to start the time delay also from the foot pedal. So what I'm going to do is I'm just going to splice into that connector here, into that wire here, right up to the other side of that time delay. So now what happens is, when we plug in, we'll have power at those two blocks. Power will be, waiting here and waiting here. Actually, it's going to go through the, and technically it's not because it's an open circuit at this point, but just bear with me, play along. It'll go through the relaxed contacts and be waiting right here. But we're not going to be able to complete that here until we step on the pedal. We step on the pedal, that will complete the circuit through the coil here. That relay will energize, sending power to the primary, and we start welding. But at the same time as we step on the pedal, we also start the time delay. And then after however many seconds we set, that will energize, braking here, which will kill the coil, which then this will relax, and then that will kill, and then everything's done. Make sense? Now, there's other ways I could have done this. There's probably half a dozen ways I could have done this. I could have used a digital relay. Now, I've only used a few digital relays in the past with some other circuits. My burnout oven and the forge used digital relays. But with those, you have to have, and I also used one for my vacuum pump, so I've used 3 of those on 3 different projects. But with those, you have to have a DC source. Like the digital relay takes a lower voltage, like 12 to 30 volts DC, to turn it on, and then it can handle an AC load. If I would have utilized one of those, I would have had to have had an AC to DC transformer. That would have been one more component. And plus, this relay here was like $5, and I still would have needed the timer relay. This, I think, was 10 or 15, I think 10. But this was 5. Digital relay, I think they started around 15 or 20. I think the ones I've gotten in the past were about 20 or $25 or something. So this, by using these, by doing it this way, there's only a couple of components. The wiring isn't hard, and it was cheaper. So let's take a look at the actual installation here. I wired this up last night. Sorry I didn't record it. But it's just a very tedious, boring process of, you take a wire, you strip the wire, you connect the end, okay? Now, I soldered all of the ends on. I use these types of connections here for everything. And I soldered the wire on, and then I put a piece of heat shrink over it. You could crimp it, but my crimpers are junk. When I try my crimpers, they're still loose. They're just the cheap, probably $3 crimpers I got at Kmart 20 years ago. So I do need to invest in a better set of crimpers. Until then, I solder the wires on, and I know that'll work. I know that'll last. So if we take a look at how I laid this out, and this is one thing I wish I would have done a little bit differently. I cut this board before I ordered the relays. I made the board before I knew exactly how I was going to do it. So I just had enough room to put the relay sockets here. This gray cable right here, this is the power coming in. This black cable here is from the foot pedal. So the foot pedal wires, they come in and wire into here. Power supply wires, they come in on this back side and right into here. The junction blocks, there's one junction block here, another junction block here. This is the socket for the timer relay. This is a socket for the other relay. And anytime I'm wiring something, I try to keep the wires as neat as I can. I really don't like bird's nest of wires just stringing all over the place. So each wire is as short and as direct as I could make it, and I tried to group wires together so I could just kind of tie strap them together in place. It just looks better, looks nicer, but everything here is a little bit cramped to begin with anyways. But it does fit. So the relay, it just plugs in to the socket like so, and the timer relay plugs in to socket right here. It can only go one way. The spacing of the pins is such that you can't put it in backwards. So that goes in just like that. That's it. So this is ready to run right now. The thing is though, if I were to use it now, right now I don't have anything to lock the jaws down. Let me get this all in frame here. I don't have anything to lock that top jaw down. So when I use it now, basically I just wrap electrical tape around the jaws to put some pressure on it. But that's about to change because that's why I bought this. This will mount somewhere here to just push right here to clamp that down. If I turn this sideways and get a better view of that. Okay, like so. So there's the top jaw here, right? So again, this will mount like that, just to push that top jaw down. So, as it is now, that won't quite fit on there. I'm going to have to make a plate or something to mount this to, and then screw to the top of that. So, and I haven't yet figured out exactly how I want to do that. So, let me think about that a bit and get that done. I'll come back when that's done and I'll show you what it looks like, and then we'll test the thing out. Okay, so it's not exactly how I wanted the latch to work, but I mean it works, but it's not how I pictured it being mounted. But it's fine, it does its job. Right now it's locked, it's pushing down on the top bar, clamping a piece in there. Right now I've got the timer set on, I think about 4 seconds. So let's give it a try here. All right, I'll put about, I don't know, 3 or 4, 5 more welds on that piece, and then we'll see how well it sticks it together. So here's just a better view of the lock here. So just run it down and it clamps in place. So you see it does work. But maybe someday I'll put something on it that looks a little bit better. But for now it's fine. Also, I've been thinking about making an enclosure to put around there. I mean, because it is a lot of, 120 power voltage right around there out in the open. But I'm thinking I'm probably the only one who's ever going to use this. And I know not to go sticking my fingers down in there with it plugged in, which it is not plugged in now. And it's one of those things where, for me, it's fine, but I don't think I'm going to loan it out to anybody unless I do put a cover on it. But I think it's kind of nice to be able to see everything right here, so if anything does come loose or start to smoke or chafe or anything like that, I can see it right away. So for now, I'm just going to leave it as is. And, for a shop tool that will probably only get used 2 or 3 times a year, I'm going to call this one done. So anyways, let's take a look at that piece that I tacked together here, and we'll see how strong it is. So I know about 4 seconds ago I said I'm going to call it done. However, there are a few things about it that I may change eventually. For one, the points that actually do the welding are actually made out of brass, and I was doing some reading earlier that they should be copper. Either copper or a chrome brass. So, you want something that has as least as resistance as possible. And I did notice that, after 4 welds, those were getting pretty warm. And also, this took 4 seconds per weld, and from what I remember, from what I think, it should only take about a second or so. So I think the brass tips might have too much resistance. I don't know. So I might buy a copper bar and turn some new points out of copper, see how that works. Also, when I had this in there, I didn't have it really clamped down all that great. The one piece had a little bit of a curve to it, so it didn't fully make. In fact, that weld here isn't actually welded at all. That's loose. So I'm not expecting this test to work out very well, but we'll just see how tough that is. Man, that one of them snapped over here. But again, that was a side that it just wasn't clamped down at all. Because this bracket that I bent, again, it had a bow in it this way. So these down here weren't actually even contacted. I really only got 2 welds on this, maybe 3. But yeah, that's bending. You can see how that is here. So I got 2 good welds on it. Out of 6, I got 2 good welds, just because I didn't notice that one of those was actually bent a little bit. As you can see, I'm bending those, and they're stuck on there pretty well. So yeah, a bad example, a bad practice piece, but 2 really good welds here. So I'm happy with that. I'm pleased with that. So I do have a few ideas. It would have been funny if it would have just fallen apart when I did that. I do have a couple of ideas for some projects coming up down the road that will utilize that spot welder. So when I'm ready to actually start those projects, I'll have the tool ready to go to do it. So I'm going to call this one done for now. And as always, thanks for watching.